Sketch the graph of the equation with a double root at -2, a single root at 5, a triple root at 0. Assume the leading coefficient is negative. All right, so these are our intercepts. -2, single root at 5, 1, 2, 3, 4, 5, and a triple root at 0. So let's see how many roots there are. There's 2 here, 1 at 5, and then 3 at 0. So that would give us 6 total, which makes it an even polynomial. And remember, even ones start and end in the same place, but this one says that the leading coefficient is negative. So it might look something like that. It's going to start low and end low. Now let's talk about these double roots. Remember, a double root means that it touches it and then it turns around. So it doesn't cross through it. So it's going to come up, hit -2, and then start heading back down. It's got a single root at 5, so that means it'll cross at 5, and then a triple root at 0. So when it is a triple root, that's when it bends at that number. So it's going to come up at 0, and then be like, whoa, but still head that direction, but it's going to be a little bit of a bend. And then it has a single root at +5. So it's going to come back and just cross right through 5. So when it's even, it hits at that 0, turns back around. If it's odd, if it's 1, it just crosses right through it. And if it's odd and it's not 1, it bends at that number. So there's the graph. Now as far as writing the equation for it, let's see, we have a double root at -2, so that could be written as x plus 2 to the second power, right? Double root. Single root at 5, and then a triple root at 0. That can be written with an x cubed on the outside. So here is our function. We just need to multiply this out now, which, we've done it. It can be kind of a pain, but it's okay. Let's do this x plus 2 squared first. I don't know what just happened there. Let me see if I can undo that. There we go. Oh boy, everything disappeared. All right, x plus 2 squared, so we'll keep our x cubed. And I'm going to write my x minus 5 right after that. And then I'm going to do my x plus 2 squared. So it's square the first term, multiply them together, and multiply by 2. So it'd be 2x times 2, so plus 4x. And then square the last term. 2 times 2 is 4. Okay, we can go ahead and distribute this x to the third into these. So that would be x to the fourth minus 5x to the third. And then our last step is to just make sure we multiply all this stuff, which that's going to be a true delight. A true delight. So first, if I get them with the x to the fourth, we're putting 4 more x's on everything. So instead of x squared, it'd be x to the sixth plus 4x to the fifth plus 4x to the fourth. All right, now we got to give everything that third power. So negative 5x to the third times x squared would be negative 5x to the fifth. Negative 5x to the third times 4x would be negative 20x to the fourth. And then negative 5x to the third times 4 would be negative 20x to the third. So we combine our like terms here. We'll say f of x, or you can say y equals x to the sixth. 4 minus 5 is negative 1 minus x to the fifth. 4 minus 20 is negative 16 x to the fourth. And negative 20 x to the third. What am I forgetting here? Oh, and the lead coefficient is negative. Oh boy. So that should be like negative x to the third there. But the nice thing is, that's a pretty easy fix, because we can just make it all negative. the opposite now. F of x equals negative x to the sixth plus x to the fifth plus 16x to the fourth plus 20x to the third. Phew! Glad that was a quick fix. That one was pretty tough. I'm not gonna lie. Now they're gonna give us the graphs, and we just have to write out that function. So first thing I see is this starts on the bottom left, ends in the top right, which means it's an odd function. And I see that every time it just crosses through. So that's a multiplicity of 1. So it crosses at negative 3, so that would be written as x plus 3 x plus 3. It crosses at negative 1, so that would be written as x plus 1. And it crosses at positive 2, which would be written as x minus 2. It goes up and to the right, which means it has a positive lead coefficient. So it does not matter the order we multiply these. I'm just going to FOIL these first two. So it would be x squared plus 1x plus 3x plus 3. So if we combine our x's there, we have x squared plus 4x plus 3. But we still need to multiply that with the x minus 2. So I see down here it says write it in factored form. That's what I have in the black. And then write it in standard form. That's what we're working on right now. So let's get them all with the x. This just bumps everything up an x. X to the third, 4x to the second, plus 3x. If we multiply them all with negative 2, that would be negative 2x squared, negative 8x, and negative 6. And then it's just combining the like terms. So y equals x cubed plus 2x squared minus 5x minus 6. Okay, not bad, not bad, not bad. Or is it? Oh dear. Oh dear me, oh my. Let me make this smaller. You know what? We can still see it if it's a little bit smaller. And look at me, I'm so important. I want to stay large on the screen. Get out of here, this guy. All right, it crosses at negative 3. So that would be written as x plus 3. It crosses at 2 and 4. So that would be written as x minus 2, x minus 4. Is there any other information I need here? I see it's an odd function. Looks like it's to the third power. Leading coefficient's positive, so there we go. That one's good. So let's pick a set, FOIL them out. X squared minus 2x plus 3x minus 6. If we combine negative 2x plus 3x, it would be positive x. We still need to multiply this by x minus 4. If we multiply them all with an x, the x to the third plus x squared minus 6x. If we get them all with that negative 4, we have negative 4x squared, negative 4x, and positive 24. Cleanup time, and then we got clean up all your functions everywhere. Clean up, show your work, pretend you care. Hey, Barney, x cubed minus 3x squared minus 10x plus 24. Hey, a good thing to check for that plus 24 should be the y-intercept. Does it cross at 24? Ah, it does. Oh my gosh. We're so smart. So this one crosses at 2 and 4. But you'll notice that it hits that 2 and then turns around. So remember, that means a multiplicity, an even multiplicity. And if we're trying to go with the simplest one, that could be written as x minus 2 to the second power, right? That's hitting 2 and turning back around. It also crosses through at 4, so that would be written as x minus 4. So if we were to FOIL out x minus 2 squared, that would be x squared. Square the first term, then multiply them together and double it for the middle term, and then square the last term. 2 times 2 is 4. Now we need to multiply this with the x minus 4. Hit them with an x to the third minus 4x to the second plus 4x. Hit them with the negative 4, negative 4x squared, positive 16x, and negative 16. We're ready for a final cleaned up answer. Y equals x cubed minus 8x squared plus 20x minus 16. So in theory, it would cross the y-axis at negative 16. Our graph doesn't show that far down on ours. What in the world? This one looks like it starts and ends in the same direction. So it's an even function. It starts and ends up top, so it's positive. So let's write out with intercepts. It crosses at negative 4, x plus 4. It crosses at negative 1, x minus 1. Whoops, this should be x plus 1. It crosses at positive 1, which would be x minus 1. And it crosses at positive 4, which would be written as x minus 4. There it is in factored form. Now when I'm doing this and trying to multiply it, I notice I have a plus 4 and a minus 4. So I'm going to kind of pair those up, because that'll be a difference of squares. Same with the x plus 1, x minus 1. X plus 4, x minus 4, you square the first term, put a minus, square the last term. Same thing with plus 1 minus 1. Square the first term, put a minus, square the last term. There we go. We FOILed both those out that quick. Now we just need to multiply these. So x squared times x squared is x to the fourth. X squared times negative 1 is negative x squared. Here we have negative 16x squared and plus 16. So that's clean it up. Y equals x to the fourth. For the x squareds, I have negative 1 minus 16, negative 17x squared plus 16. Hey, does that mean it crosses the y-axis at positive 16? Oh, it certainly does. It certainly does. That was number 4. How about number 5? Oh, state the degree, state whether the leading coefficient is positive or negative, and write it in factored form. Oh, great, they're saving us a step. We don't have to multiply it out. That's good. Degree of the polynomial. Well, that could be a little tough. I see that it's even. Now let's look here. We've got a bend right there. So remember, bend happens when it's an odd degree. So we could say like this has a multiplicity of 3. So that would be 3 degrees right there. And then it crosses over here. So that would be a multiplicity of 1. And then it crosses over here. So it would also have a multiplicity of 1. So you have 1, 2, plus 3 is 5. So we could say the 5th degree. Oh wait, is it just? Oh, okay. I think earlier I said it was even because I thought that was like the y-axis, but it's not. It's part of the graph line. So it's the 5th degree. State whether the leading coefficient is positive or negative. It starts low, ends high. So that means the LC is positive. Are you sure? Yeah, I'm positive. Use that joke twice. All right, and then write the polynomial in factored form. Move down. Here we go. Here we go. All right, so we've got the bend at negative 3. So initially, that would be written as x plus 3. But it's bending there, so it has a multiplicity of 3. Or it could have a multiplicity of 5, 7, 9. It could have an odd multiplicity. We're going to go with the simplest one, which would just be to the third power. It crosses at positive 1. So we're going to write that as x minus 1. And then it crosses again at 5. So that would be written as x minus 5. It just wanted it in factored form. So we're all done. We got one more of those. Holy smokes. All right. So I see it hits the x-axis and then turns around, which means it has a multiplicity of 2. So there's 2 there. It does it again here, so there's 2 more. So we're at 4. Then it crosses 5. Then it crosses again 6. So it's 6th degree. And when it's even, it starts and ends in the same place. This starts and ends up top, which means the lead coefficient is positive. Are you sure? I hope you said it at home. I hope you did. And then we need to write it in factored form. So we have that multiplicity of 2 at negative 7. So it could be written as x plus 7 to the second power. Then it has a multiplicity of 2 at negative 4. So that would be x plus 4 to the second power. It crosses through at 0. So you could say x minus 0, and we're going to clean that up in a minute. And then it crosses through at 2, which would be x minus 2. Now that x minus 0, I just didn't have the space for it. It should just be an x out in front. So we have x, we have the x plus 7 squared, we have the x plus 4 squared, and we have the x minus 2. Remember, the order of the parentheses does not matter, as long as you have the right symbols with the right numbers with the right exponents. So that was fun.